Hello, today we'll be going over the next 5 problems of the 2020 AMC10 A. So problem number 6 states, how many 4-digit positive integers, that is integers between 1000 and 9999 inclusive, have only even digits that are divisible by 5? So let's say our 4-digit integer has 4 spots in it for the 4 digits. The even integers are 0, 2, 4, 6, and 8. So over here, it says that they only include even in digits and are divisible by 5. If it is divisible by 5, this means that it must end in either a 0 or a 5. And seeing that there is no 5 in our list of even integers, we know that it must end in the 0. So therefore, we know that there's one choice for the last digit, which is the 0. Now let's look at the first digit. The first digit can be any of the even digits, but it cannot be 0 because a number cannot start with 0. So therefore, we have 4 possibilities to pick a 2, 4, 6, or an 8 for the first digit. The second digit can be any of the numbers because the second and third digit won't affect the divisibility by 5. So we can have 5 choices for the second digit and 5 choices for the third digit, giving us an answer of 4 times 5 times 5, which is 100, which is also answer choice B. Now moving on to the next problem, which is problem number 7. The 25 integers from -10 to 14 inclusive can be arranged to form a 5 by 5 square in which the sum of the numbers in each row, the sum of the numbers in each column, and the sum of the numbers along each of the main diagonals are the same. What is the value of this common sum? So there's a trick to solve these types of problems. So first you take all of the numbers that should be in the n by n square and add them. In this case, it's the 5 by 5 square, and the numbers in the square range from -10 to 14. Adding all of these numbers up gives us a sum of 50. A simple way to quickly add these up is by saying that from the numbers -10 to +10, those all cancel out and just add 11, 12, 13, and 14. Now, in the n by n square, what you want to do is to take the number which you have up here and divide it by n. In this case, we have a 5 by 5 squared, so you would divide this by 5 and get our answer of 10, which is answer choice C. Now moving on to the next problem, problem number 8. What is the value of 1 plus 2 plus 3 minus 4 plus 5 plus 6 plus 7 minus 8 plus ... plus 197 plus 198 plus 199 minus 200. A quick and speedy solution to do this is by grouping them by 4s, because we know that there are 3 numbers that are added and 3 numbers that are being subtracted, all the way up to 200. So let's start adding some of these up. 1 plus 2 plus 3 minus 4 gives us a sum of 2. 5 plus 6 plus 7 minus 8 gives us a sum of 10. The next set gives us 18, and so on, until we come over here with 394 once we sum this up. So now we see that we have an arithmetic sequence which we can easily sum up. So the way we can sum this is by taking the first number, adding it to the last number, dividing that by 2, and multiplying by the number of terms. In this case, the number of terms would be 50. And that is because we are grouping the terms into 4s, pairs of 4. And if there are 200 terms, then that would make 50 pairs. So therefore, multiplying all of this out gives us an answer of 9,900, which is also answer choice B. Problem number 9 states, a single bench section at a school event can hold either 7 adults or 11 children. When n bench sections are connected end to end, an equal number of adults and children are seated together will occupy all the bench space. What is the least possible positive integer value of n? So in this case, you want to find n, which is the number of bench sections that are connected end to end. So if we want the same amount of children and same amount of adults, we want to find the LCM. And since there are 7 adults and 11 children, we find that the LCM of 7 and 11 is 77. Because the two are relatively prime, we multiply them together. So now we find out how many bench sections we want to connect. Well, for each adult, we can fit 7 adults in each bench section, plus 11 kids in each bench section. And if we have 77 of each, the answer becomes 11 plus 7, which is equal to 18, which is answer choice B. The next problem states 7 cubes whose volumes are 1, 8, 27, 64, 125, 216, and 343 cubic units are stacked vertically to form a tower in which the volumes of the cubes decrease from bottom to top. Except for the bottom cube, the bottom face of each cube lies completely on top of the cube below it. What is the total surface area of the towers, including the bottom in square units? So the way, if we were going to visualize this, is that it's going to be 1 cube at the bottom, another cube on top, third cube on top, fourth cube on top, and so on. So let's study one of the cubes here. In this case, 4 of the faces on the 4 sides would be showing if this is in 3D. The bottom face would not be showing, and the top face would not be showing. So basically, the surface area of a cube would be 6s squared. But since we only have 4 faces showing, it would be 4s squared. So now let's sum this up for all of the cubes. So we know that the amount of cubes goes from 1 squared, a 1 by 1 by 1, all the way up to a 7 by 7 by 7. And we can find this by taking the cubic areas and taking the cube root of them. This would give us the side length of one of them. So by knowing this, we can calculate for each of the side lengths from 1 to 7, we can calculate 4s squared. And by adding all of them up, and by adding them all up from 7 to n equals 0, then we would get a total sum of 560. But there are a few cases we have to take in mind. First, we didn't include the bottom one over here. The bottom cube is a 7 by 7 by 7. We have to include one of the faces, and one of the faces would be a 7 by 7, which is 49. Oh, sorry for the color change. And now, the other thing we have to look at is, see, if we stack one cube on top of the other, the bird's eye view would look like this, where we still have all of this space which we have not taken into consideration. But let's say we stack all the cubes one on top of each other over and over again. How will the bird's eye view look from here? Well, we would include the surface area of the first cube, which would be this section, the surface area of the second cube, which would incorporate this section, the surface area of the third cube, which would incorporate this section, the fourth cube, which would be this section, and so on. So you see that the surface area from the top view would just be the largest cubes in the set, the largest cube's surface area for one side. So if we have it as a 7 by 7, we would, from the top view, we would have to add back 7 times 7, which equals 49 cubic units. And then adding all this up gives us a total of 658, which is answer choice B.